In this video, we're going to talk about significant digits. The reason why we use them is chemistry being a laboratory-based class like it is, we go around and make different measurements. Sometimes the instruments that we use will have different precision levels, meaning that they can measure something more accurately than say maybe another instrument. So it's basically all about uncertainty. So say, for example, if I were going to see how long it takes someone to run a 100-meter dash, and I took a stopwatch, which a stopwatch can measure minutes, seconds, down to the milliseconds, or if I took a clock that could only measure the minutes, the stopwatch is going to be much more precise. So if I use the combination of the two clocks, my final answer could not be more precise than my least final answer. So let's go ahead and jot that down. I think that's important to realize why we have to even do anything with significant digits, because your final answer cannot be any more precise. So your final answer cannot be any more precise than your least precise measurement. So it's kind of like the old saying, you're only as strong as your weakest link, or a chain is only as strong as the weakest link. So your final answer can't be any more precise than your least precise measurement. And we'll do a little bit more with this in just a little bit as far as calculating things. But anyhow, these are rules for significant digits. So these are significant. Sometimes you hear them called significant figures or significant digits. So significant figures, so sig figs, or significant digits, digs. That's supposed to be an I. Okay, so all non-zeros are significant. So let's say if I had a number that said 123.4. So in this, all four of these numbers are non-zero. So this particular one would have 4 significant digits. Or if I had a number that said 72.8, this number would have 3 significant digits because all 3 of these are non-zero as well. Alright, so if we move down to our next rule, zeros between significant digits are significant. So this would be if I had a number, say, like 808. We know the 8 is significant because it's non-zero according to rule number 1. We know that this 8 is significant for the same reason, but this 0 now becomes significant because it's sandwiched in between 2 significant digits according to rule number 2. So I kind of refer to this sometimes as the sandwich rule. Or another example would be, let's say if I had 9,009, even if I had 2 zeros. We know that's significant because it's not 0. This one is significant because it's not 0. Now both of these zeros become significant because once again they're sandwiched in between 2 significant digits. So whereas we said this one had 3 significant digits, this one has 4 significant digits. Alright, so rule number 3, a 0 that comes first or a 0 that comes last after the decimal point is significant. So an example with this would be if I had, let's say, 107.0. Okay, so now let's go through here. This 1 is significant because it's not 0. This 7 is significant because it's not 0. But now we look at the first 0. This first 0 becomes significant because, once again, the sandwich rule, it's sandwiched in between 2 significant digits. But if we look at this 0 comes last after the decimal point. So according to rule number 3, it makes this 0 significant also. So this number has 4 significant digits. The key here, I think, to remembering is this word right here. It's got to come last after the decimal place. So say, for example, if I've got, let's say, 0.0001. Well, somebody might say, okay, well, these zeros are after the decimal place, so all these are significant, so this must have 4 significant digits. That is incorrect, because no 0 comes last after the decimal place. The last digit here is actually a 1. So in this number, there's only 1 significant digit. These zeros here basically just serve as placeholders. They are not significant. But now if I were to say 0.0001 and then put a 0 there, now this 0 becomes significant because it is last after the decimal point. So This one becomes significant because of rule number 3. This one is significant because of rule number 1. And once again, these zeros are not significant, they're just placeholders, so this number would actually have 2 significant digits in it. Alright, if we look at number 4, so explicitly placing a decimal at the end of a number makes the 0 before it's significant. So an example of this would be, so if I had the number, let's say, 230. This number has 2 significant digits because the 2 is not 0, the 3 is not 0, and there's no rule that we've encountered that would make this 0 significant. It's not sandwiched in between anything. It's not last after the decimal place. But if I were to explicitly place a decimal at the end of this number, say 230, and put a decimal there, this decimal actually makes this 0 become significant now, and this number actually has 3. Well, you may say, okay, well, what's really the difference between this? Both of these are 230. Well, when you write down 230 without a decimal, I'm not exactly sure if this is not an estimate. Maybe your measurement was 229.9 and you just rounded to 230, or maybe it was 230.1 and you just rounded to 230. But when you explicitly put the decimal in after the 0, you are saying this is exactly what it is. This is an exact number. I've actually measured it. I have enough precision in my instrument to tell you it is exactly 230, whatever it is you were measuring. Maybe, I don't know, length, meters, volume, liters, whatever else. But this dot, or the decimal, just makes this 0 become significant. And in the next video, we'll actually do some calculations, or in a future video, we'll do some calculations with significant digits.